Beautiful people, and welcome. In this video we are graphing quadratic functions. Now this is a very specific form. This is called the standard form, and you've seen this before a lot in our factoring unit or when we were solving quadratic equations. So you're going to have an ax squared plus bx plus c. You must memorize that this is called the standard form. So how do we graph something in standard form, specifically the quadratic function? Step number one, we're going to find the axis of symmetry. So what you're going to do is you're going to take your b value here with the symbol, and you're going to place it inside the parentheses with a negative on the outside. You're going to then take your a value, which is here, again, with the symbol if it is negative, and you're going to multiply that number by 2. That's going to give you an x value. You're going to end up with having something like this. X equals a number. This is your axis of symmetry. Now, to find the vertex, which is the most outer point on the curve, you're going to take this number. You're going to plug the value into the original equation. So you're going to take this x value and you're going to plug it into this right here. So how will this look like? You will end up looking like a point. You have your x value and your y value, and that would be your vertex. So for example, let me actually shift this a little bit lower so you guys can see. This is what you would have. You would have your equation. And then inside for your x values, you would replace that with your number from step 1. So you're going to replace that and you're going to solve for y. Your y answer is going to be y part of your point. Your x that you used for your input is going to be your x value. So right now we have the axis of symmetry. Now you have your vertex point. Next, what you're going to do is you're going to find 2 more points. Let me shift this down. You're going to find 2 more points on your curve. So how do you do that? You're going to choose any x values. Pick any inputs that you want. Now, I always recommend using something pretty. So what you're going to do is you're going to take a look at the x value of your axis of symmetry. So in step number 1, you have an x value. Choose numbers that are really close to it. So I would recommend going 1 or maybe 2 jumps above that number and finding out what that is. So for example, if my axis of symmetry x value was 2, I would choose 3 and 4. Or if my axis of symmetry was -5, I would choose -4 and -3. I would choose the numbers that are close to it. Take those numbers, whatever numbers you choose, you're going to plug it into the equation, the original equation, one at a time, and then solve for y. Basically, for this step, you're just plugging and chugging. Take a number, put it in the equation, get your output. That's what you're going to have. Now, for step number 4 is you're going to take those points that you just found in step number 3, and you're going to reflect it across the axis of symmetry. What I recommend is to count the number of jumps from the axis of symmetry and do it to the other side. So what does that mean? Let me shift my paper up here. So for example, if I have a point, here's my axis of symmetry, here's my vertex. So if I have one jump to the right, I'm going to reflect that by doing 1 jump to the left. And now I have reflected that point across the axis of symmetry. So if I have 2 jumps to the right, I'm going to do 2 jumps to the left. So that way you have points on the right side of the axis of symmetry and points to the left side of the axis of symmetry. So when you connect them, it's going to be smooth U with arrows, and you'll have points on the right and the left-hand side. Once you have all of that, you are done. Go ahead and do some examples. So I'm going to have my steps out in front. So we have our 4 total steps. And let's start with the first one. Step number 1 is to find the axis of symmetry. So how do we do that? Well, let's go ahead and write out the formula, which is x is equal to negative, or the opposite of b. Make sure b is in a bubble. 2 times a. Now what are our a, b's, and c's? Let's go ahead and say this one's a. This one with the symbol is b. And this one with the symbol is c. So I have a, b, and c. So plugging in our b value is 12. 2 times a, our a value is 2. So I have negative 12 divided by 4 times 2, which is, 2 times 2, which is 4. And negative 12 divided by 4 is a negative 3. Now this is our x value, and this is our line of symmetry. This is your step 1. Step number 2 tells you to use this x to find the vertex point. So I'm going to copy down this equation, our original equation, 2x squared plus 12x plus 19. And here I'm going to copy it down one more time, but this time anytime I see an x, I'm just going to put a parenthesis bubble there. And what our goal is to solve for y. So when our input is the x of negative 3, we want to know what our output is. Now for this, I would recommend using a calculator in case you have any hiccups there. So on our calculator, what I'm going to do is I'm going to type kind of exactly what I see. So I'm going to type in 2 times, let's see if I can show you here. So don't mind here what's on top, but I want to show you what I'm going to type in. I'm going to type in 2 times, so parenthesis, negative 3, parenthesis. I'm going to square that. Now my calculator doesn't have a square button, so I have to use the caret 2. And then I'm going to say plus 12, oops, no parenthesis here, plus 12 times negative 3, and then plus 19. So this is what I'm typing in, exactly what I see here. That way when I press enter, they will give us a value. And so just like, so my calculator gives you what it did, so you know. So 2 times negative 3 squared plus 12 times negative 3 plus 19, and our answer is 1. So when our input is negative 3, our output is 1. So this is your vertex point. Now step 3, I'm running out of room here, but that's okay. We can always shift this example somewhere else. Step number 3 is asking you to choose 2 other values for x. I'm going to use some space here since I have these. This is going to be my step 3. So right now I have a vertex point at negative 3 and 1. So I'm going to choose numbers that are very close to that. So I'm going to choose, for example, negative 2, and I'm going to choose negative 1. The reason I'm going like higher numbers is because I don't want too big numbers because they might be out of my field of vision. So I'm going to take my original equation, and anytime I see x, I'm going to put a bubble. And inside the bubble, I'm going to start out with my negative 1. And then I'm going to do exactly the same thing for my negative 2. So when our input is negative 1, I want to know what the y value is. And when our input is negative 2, I want to know what the y value is. So just like we did before, I'm going to type this into my calculator all at once. So 2 times negative 1 squared plus 12 times negative 1 plus 19. I'm going to press enter. So when my input was negative 1, my output was 9. And one more time, we're going to type all of that out, but this time my input is negative 2. So 2 times negative 2 squared plus 12 times, I forgot where the times symbol was, times negative 2 plus 19, and that one is 3. So that's step number 3. I'm going to go ahead and maybe excuse this example number 2 for right now. I'm just going to keep doing a bubble. So then step number 4 is to flip over your point across the line of symmetry. So how do we do that? Well, let's go ahead and actually start graphing for step number 4. Here's your x and y axis. We're going to start out by marking where your line of symmetry is. And your line of symmetry we found in step number 1, which was negative 3. 1, 2, 3. Now it is your x, and it's going to be a vertical line. So it's going to go up and down. This is your line of symmetry. Now you have 3 points right now. You have your vertex point, and you have your 2 other points that you have acquired. So let's start off with the vertex, which is negative 3 and 1. This is your vertex point. You have negative 1 and 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Almost ran out of space, but that's okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's negative 1 and 9. And then I have negative 2 and 3, which is here. So notice for the reflection across the axis of symmetry, you're going to jump. So for example, this point is one jump away from your axis of symmetry. So this value of y being 3 stays the same. However, now we're going to jump to the left of the axis of symmetry, and we're going to put a point here. So same thing here for this point. This point is 2 jumps away from the axis of symmetry. So I'm going to jump 2 points away to the left-hand side, to the opposite side. Now your y value, your height, stays the same. It's just the x value that changes. So we're going to mimic that. Now you notice you can kind of already see the look of the quadratic function, how it's going to show you that u. So here it is. We're going to connect. Make sure it looks like a U, like a smiley face. No sharp edges, and it must have arrows pointing out. Let's do one more example. I am going to shift this off to another sheet of paper, so that way we can use all of the space that we have. So what we have here is example 2. Negative 1/2 x squared plus 4x minus 7 is equal to y. Now, immediately when you see a negative, you don't have to do anything with it. Just know that this is going to be a decreasing function. And I'm going to abbreviate function with FNC. And what that means is now it's going to be a frowny face. It's going to go upside down. It's going to have a reflection across the x-axis, meaning we have a decreasing function. That's just something we keep in the back of the mind. It will work itself way out. Like with the points that we get, it will automatically look like this. And if it doesn't, then we know we made a mistake. So step number 1, we want to find the axis of symmetry. Again, what's the formula? X is equal to negative b divided by 2 times a. Again, we have to figure out what's our a and b and c's. So with the symbol, make sure you always grab the symbols. That's our a. Oops, I thought that was a highlighter. It is not. That is our b, again with the symbol, and then our c value. So we have a is negative 1/2, b is positive 4, and c is negative 7. So what do we have? We have a negative b, which is positive 4, divided by 2 times negative 1/2. So I have a negative 4 divided by 2 times negative 1 divided by 2. And I'm just kind of doing this the long way just to show you what we have in the denominator. So I have negative 2 divided by 2. Just looking at that, take a look, you guys. 2 divided by 2 is 1. So I have a negative 4 divided by negative 1. And then I have negative and negative makes a positive, so my output is 4. So that means my x value is 4. So then for step number 2, again, this is your axis of symmetry. Step number 2 is your vertex point. That's where you take the original equation and then take the axis of symmetry value, that x value, and you're going to plug it in. So I have negative 1/2 bubble squared plus 4 bubble minus 7, and we want to know what our output is. So I'm going to plug in or substitute in instead of x, I'm going to put now 4. So now again, I'm going to type this into my calculator. Now the fraction is going to look a little different. So in my calculator, what I'm going to do, my calculator doesn't do fractions, so I have to do a negative 1 divided by 2, which it is a fraction. So let's see if you guys can see that. So I'm going to do a parenthesis, negative 1 divided by 2, and that gives me my fraction. Then I'm going to say parentheses 4 parenthesis squared, and I'm going to cheat a little bit and look because I already forgot what I have. So then I have 4, oops, let's look because I already forgot. 4 squared plus 4 times 4 minus 7. So let's make sure I have this correct. Negative 1/2 times 4 squared plus 4 times 4 minus 7. And again, let's make sure that's good. It is good. And our output is 1 again. How did that happen? Just a coincidence. It's not always going to be 1. So y is 1. So what does that mean? That means our vertex point is at x is 4 and y is 1. Step 3 is to use that equation again, that original equation, and plug in 2 more points. Create a t-chart with your x and y. Take your vertex point and just kind of write it in the middle. So I have 4 and 1. And then I'm going to choose points that are very close to 4. So for example, I always like to go smaller numbers. So I'm going to have a 3 and a 2. So I'm going to have negative 1/2 times something squared plus 4 times something minus 7. So anytime I see an x, I'm putting a bubble, and I want to know what my output is. And I'm going to do that twice, one time for that 2 and one time for that 3. So then I'm going to input 2, and I'm going to input 3, and plug and chug in my calculator. I'm going to shift this up so I can see what I'm typing in. So negative 1/2, so negative 1 divided by 2. Then I'm going to have times, so another parenthesis, 2 squared plus 4 times 2 minus 7, and I get an output of negative 1. So my input was 2, my output was negative 1. Let's do that one more time. So negative 1/2 times 3 squared plus 4 times 3 minus 7, and my output was 1/2. All right, let's go ahead and sketch this out. Now that 1/2 is giving me a little bit of anxiety, I will be honest, but that's okay. We can figure it out together. So I have, let's make this a little bit longer. So I have 1, 2, 3, 4, 1, 2, 3. So I have 4 and 1, here it is. I have 2, here's 2, and negative 1. And I have I have 3 and 1/2, which is about here-ish. And that's okay. So let's go ahead and also mark up our axis of symmetry, which was at positive 4, which is here. And that's okay, you guys. Now that I see kind of what it's supposed to look like, I think we're okay. So how many jumps away is this 1/2? And that is 1 jump away. So I'm going to do 1 jump, place it here. How many jumps is this one away? 1, 2. So I'm going to do 1, 2 jumps away for this point. And now we have our 5 points and kind of already know what the shape is going to be. So we're going to draw this out. This one is going upside down. And like we said in the beginning of the question, we want it to go upside down because it is a decreasing function with an a value that is negative. All right, beautiful people, thank you so much for watching this video. In the next one, we will spend many minutes working on more examples. Thank you so much. Take care. Bye.